ಮಾಡ್ದೆ ಹೆಂಗಾಗೋಯ್ತು ಗೊತ್ತಾ ನಂಗೆ. ಇಲ್ಲೆಲ್ಲ ಮನೆ ಮಾಡಿ
Good evening, dear students. So in the last class, we have started with the chapter equilibrium, right? So in the last class, we have discussed about the chemical equilibrium, right? So these all things we have discussed in our previous class. So based on these things, we have also discussed the MCQs. So today we are going to start with the next concept in the equilibrium, that is ionic equilibrium. So in ionic equilibrium, we are discussing the theories, okay, that is your acid-base concepts. Okay, we are discussing here the acid-base concept. So in ionic equilibrium, what do you mean by ions? Ions are nothing but when any compound, okay, when it is dissolved in water, okay, that is in your solution, so they dissociate. They dissociate into ions. Suppose you have NaCl, okay, salt solution, NaCl. So when you add NaCl salt in the water, okay, in the water solution, so it will split into Na plus and Cl minus ions, right? So the compound which gives ions, right, in the molten state or in the solution, they are called as the electrolytes. So basically there are two types of electrolytes which we are seeing here. That is the strong electrolytes and weak electrolytes. Okay. So now as we have discussed, like if we add NaCl into water, so that will get completely dissolved. Okay. And there are some salts which will get partially dissolved. So based on that, they have classified them into strong electrolytes and weak electrolytes. So what are strong electrolytes? So these electrolytes are completely ionized. Okay, so when you add them in a polar medium, what do you mean by polar medium? Okay, polar medium, suppose like your water. Okay, so water, so H plus, okay, and OH minus. So then your HNO3, HCl, okay, HCl, H plus and Cl minus, okay. So they are polar in nature, right? When you see HCl bond, so the dipole moment is towards the chlorine, right? So polar, so there is some net dipole moment on there. So when these electrolytes, they are completely ionized when you add in a polar medium like such as water, in solution they are excellent conductors. Okay, so they conduct, okay, in the water solution they conduct. So which are the examples, like the nitric acid, HNO3, and hydrochloric acid. So these are the excellent strong electrolytes. Okay, what do you mean by strong electrolytes? So when you add them, okay, they get completely ionized, okay, in the polar medium, such as your water. Then what do you mean by weak electrolytes? Weak electrolytes, they are not completely ionized. They do not get dissolved completely, okay, in a polar solvent, and they are very poor conductor of electricity. Which are the example? One is your acetic acid, another is your phosphoric acid. Okay, so these are the two examples of a weak electrolyte. So remember that for strong electrolyte, they get completely dissolved, okay, in a polar solvent, and weak electrolyte, they do not get completely ionized or not get completely dissolved in a polar solvent. Okay, so these are the two types of electrolytes. Then there is something called as degree of ionization. Okay, what do you mean by degree of ionization? So degree of ionization is the total, the fraction of total number of molecules of an electrolyte in which it dissociates into ions. So it is given as alpha. Okay, so degree of ionization, it is given as alpha. Okay, it is the fraction of total number of molecules, that is percentage of ionization divided by 100. So how much number of molecules will get dissociate into ion? So that will tell you the degree of ionization. So how much ions will get dissolved. Okay, so it will give you the degree of ionization based on that. Okay, then so this is about degree of ionization. It is given as number of molecules dissociated as ions upon total number of molecules of electrolyte dissolved. Okay, so this is the degree of ionization. So alpha. So remember this, very important. Okay, how do we give alpha? Alpha is number of molecules dissociated as ions upon total number of molecules of electrolyte dissolved. So this is the formula which we are using. Next is Oswald dilution law. Very important concept. Okay, Oswald dilution law. So according to the Arrhenius theory of electrolytic dissociation, the molecules of an electrolyte in solution, okay, they are constantly splitting up into ions, and these ions are constantly reuniting to form unionized molecule. So what is happening? Okay, so according to Arrhenius theory, okay, so after the electrolytic solution gets dissociated, okay, when you are adding them into a solution, they are getting splitting up. Again, these ions, they are getting united. Okay, they again come, they become again, okay, they form unionized molecule. So what is happening? Okay, once the ions, they split into, okay, it splits into ions, they are again getting reionized or reunited to form the unionized molecule. So because of that, a dynamic equilibrium is existing between the ions and the unionized molecules. Okay, so what you can see that so a dynamic equilibrium, so some molecules, they are getting split into ions, and other molecules, okay, after some time, what is happening? These molecules are getting reunited to form an ionized molecule. So what is happening? A dynamic equilibrium is existing between the ions which are formed and unionized molecule of the electrolyte, okay, in the solution. So who pointed this? So this was pointed by Oswald. Okay, so Oswald. So because of that, they gave the Oswald dilution law. Okay, so you can apply this for the different system. Okay, so you can apply this different system. So if you consider a binary solution, okay, if you consider a binary solution AB, so AB, what it will do? It will split into A plus B, right? When you add them in a polar solvent, what it will do? It will dissociate into A plus B. So so dissociation constant, okay, it is given as K is equals to concentration of A plus into concentration of B minus divided by concentration of AB. Okay, so this is the formula which you have to remember. Then for very, very weak electrolyte, okay, so K is equals to C into alpha square. So alpha is equals to root of K by C. So this also you need to be, you have to remember this. Okay. Next is common ion effect. Okay, this is common ion effect. So the degree of dissociation of an electrolyte is suppressed by addition of another electrolyte. So after you add, so the degree of dissociation, that is alpha of an electrolyte, how it is suppressed, how it is minimized by addition of another electrolyte. So for a weak electrolyte, what you're doing, you're adding, you're suppressing, okay, you're suppressing by adding another electrolyte. What it contains, it contains a common ion. So this is called as the common ion effect. Suppose we have acetic acid, okay, so we know that acetic acid is a weak electrolyte, okay, and how its ionization is suppressed, okay, by adding the concentration, when you are adding a HCl. Suppose you have to add a concentrated strong acid, because acetic acid is a weak acid, okay. So when acetic acid will split, it will split into acetate ions and H plus ions, but the amount of H plus ions released here, okay, it is getting suppressed. Why? Because we are adding in this weak acid, we are adding the strong acid, okay, and we know that strong acid, okay, H plus ions produced will be more. So what you can see in both these acids, what is common is your H plus ion, okay. So the common ion is present. So because of this, this is called as what? It is called as the common ion effect, okay. This is called as what? Common ion effect. So if you consider the solution like your sodium acetate. Now, similarly, if you take sodium acetate, so acetate ion is the common. Okay. Similarly, if you have NH4Cl, ammonium chloride or NaOH, to ammonium hydroxide. Okay. So what will happen? It will suppress the dissociation of ammonium hydroxide. Why? Because the common ion will be either your NH4 plus or the OH minus. So this you have to remember. So whenever you have a weak acid, okay, weak acid, so to that, if you are adding the strong, okay, strong electrolyte, so what is happening? What is happening? The common ion is present, and because of that, the stronger acid, it suppresses the weaker acid, and what is shown, a common ion effect is shown. Okay, so this you have to remember, very important, common ion effect. Next is the solubility. Next is the solubility. Okay. Solubility product. So what do you mean by solubility product? It is defined as a product of the concentration of ions in a saturated solution of an electrolyte at a given temperature. Okay, it is defined as what? It is defined as a product of concentration of ions in a saturated solution to an electrolyte at a given temperature. Okay, suppose we have an electrolyte of the type AXBY, which will dissociate into AXBY, that is X into A of Y plus Y into X of B of X minus. Okay, so if you apply the law of mass action, okay, what you are going to get? So this is the this equation which you are going to get. Okay, concentration of A raised to Y plus into concentration of B raised to Y minus into Y divided by concentration of AX into BY equals to K. So this is your with respect to solubility product. So solubility product, it is defined as what? Concentration of the ions raised to the power equal to the number of ions, okay, number of times the ions occurs in the equation, representing the dissociation of the electrolyte at a given temperature when the solution is saturated. Okay, so this is about your solubility product. So solubility product is not the ionic product under all condition, but only when the solution is saturated. So saturated means till no more salt will dissolve in water. Okay, saturation means what? Till no more salt dissolves in water. So a state is reached where no more, when you add, okay, so suppose you are taking a test tube, take 1 ml of water, add slowly little salt. Okay, so first starting the salt will get dissolved in water, but then later at certain time, okay, a point is reached where when you add little amount of salt, it gets saturated, it gets what? Accumulated at the bottom. Okay, it is not getting dissolved, so that is called as the saturation point. Okay, that is called as what? Saturation point. So now we have already discussed about what is solubility, what is solubility product. So let us see the relationship between that. So what is the relationship between solubility is term applicable to all the solutes and it can be decreased by addition of a common ion. And what do you mean by solubility product? It is significant only for electrolytes and is constant at given temperature. Okay, so the definitions here are important. Okay, so next very important concept is the acid-base theory. Okay, so here the most important thing what we are studying is the acid-base theory. So there are different concepts which are put forth by different scientists. Okay, based on the characteristics of acid and bases. Okay, so here we are discussing three important concepts. One is the Arrhenius constant. Second is the Bronsted-Lowry concept. Okay, and the next one is the Lewis concept. Okay. So these three important concepts. So please don't forget the definitions. Definitions are very important. Okay. So Arrhenius concept is what? So Arrhenius, according to Arrhenius, the definition of acid. Okay. All the substances which give H plus ions when dissolved in water. So when you take, when you dissolve, okay, when you all the substances. So when a substance, okay, which containing the H plus ion, when it is dissolved in water and gives you H plus ion, then it is called as the acid. Okay, and while those which ionizes in water to furnish OH minus ions, they are called as the bases. So the substances which give H plus ions, they are called as acid, and the substances which gives OH minus ions, they are called as the base. So this is the concept of Arrhenius. Okay, very important. So please make a point. Okay. Next is the Bronsted-Lowry concept. Okay, Bronsted-Lowry concept, it is called as the proton donor acceptor concept. Okay, so according to acid, okay, according to the Bronsted-Lowry, acid is termed as the, it donates proton. Okay, it donates proton. So what does acid do? It is a substance that can donate proton. Okay, or it can hydrogen H plus 2, or it will that is only. So okay, so it donates proton. And what do you mean by base? Base is a substance which will accept proton. Okay, it will accepts. Okay, so base is a substance which accepts proton. So remember this. So what is Bronsted-Lowry concept? According to Bronsted-Lowry concept, acid is a substance that donates proton, and base is a substance which will accept proton. Okay, so important concepts. Okay, Arrhenius and Bronsted-Lowry. Next is the Lewis concept. So according to Lewis, what do you mean by acid? So acid, okay, it will, what it will do? It will accept the pair of electrons. So this is with respect to pair of electrons. So acid is a substance which accepts a pair of electrons, and base is a substance which will donate a pair of electrons. So very important. Okay. So next is ionic product of the solution. Okay, ionic. So we have discussed about the degree of dissociation. Okay, so based on that, if you have two constant, okay, so this is the formula. So when you have two acids, suppose, so this is a formula which we are going to use with respect to two. Okay, and we are comparing the degrees of dissociation. Then we have to use this formula. Next is the ionic product of water. Ionic product of water is what? The product of concentration of H plus and OH minus, okay, ions in water at a particular temperature is known as the ionic product of water. So as the value of Kw, that is ionic product, increases with the increase in temperature, so the concentration of H plus and OH minus ions also increases with the increase in temperature. Okay, so this thing you have to keep in mind. What is pKe? What is pKb? Okay, K and Kb, they are nothing but the dissociation constant of weak acid and weak base. So how do it is given as pK is equals to minus log of Ka, pKb is equals to minus log of Kb. Okay, so pH, pOH, I hope you know this. pH, what is pH? Negative logarithm of concentration of H plus ions, and pOH is negative logarithm of concentration of this. Okay, so then is the important thing, that is buffer solution. What do you mean by buffer solution? So buffer solution, a solution whose pH is not altered to great extent by addition, to any great extent by the addition of small quantities of either of acid or base ions, is called as a buffer. So there are two types of buffer. One is the acidic buffer and the basic buffer. Acidic buffer, it consists of mixture of weak acid and its salt, and basic buffer, it consists of weak base and it's strong with strong acid. Okay, so this is about your buffer. Okay, buffer solutions, acid buffer. So these are the important. So remember these formulas also. Okay, very important. Fine. So based on this, so these are some of the important points which you have to remember. Okay, when you are when we are discussing this chapter, that is equilibrium. Okay, so based on that, so let us solve the questions now. Okay, so in the last class we have discussed the questions based on the uh, so in the last class we have discussed some of the questions based on your chemical equilibrium, right? Yes. So some questions we have skipped because we have not discussed about the uh, okay, so about the ionic equilibrium. So let us discuss these questions. So this is the first question. The pH value of 10 molar solution of HCl is. So what will be the pH of 10 molar solution of HCl? A less than 0, B equal to 0, C equal to 1, and D equal to 2. How you are going to answer this? So the pH value, how do you define pH as? pH is what? pH is the, how do you define pH? pH is equals to negative logarithm of concentration of H plus ions, right? So now, what is the concentration of H plus ions, which is a solution HCl? So minus log of, what is the concentration? 10, right? Concentration of 10. So what is log of 10? Yes, what will be the answer? Log of, it is minus 1. Log of 10 is 1. Okay, so minus 1. So what is the answer? It is less than 0. Right. 0 comes what? So after 0, minus 1. Right. So it is less than 0. So concentration molarity is given 10. Okay. And the solution, we are finding the concentration pH of HCl. Okay, so we know that pH is equals to negative logarithm of concentration of H plus ion. So put the value. So we are going to get the answer as minus 1, and which is less than 0. So option number A is the answer. Okay, very simple question. Next question. When HCl gas is passed through a saturated solution of NaCl, the solubility of NaCl, what will happen to the solubility of NaCl? A increases, B decreases, C does not change, and D, NaCl is decomposed. Yes. When HCl gas is passed to a saturated solution of NaCl, the solubility of NaCl, what will happen to solubility of NaCl? Whether it will increase, decrease, does not change, and NaCl is decomposed. Yes. So what we are doing? NaCl. Okay, and we are adding HCl. Okay. So what is happening here? So common ion is there. So what will happen according to common ion effect? What will happen to the solubility? Solubility will decrease, right? Solubility will decrease. So, because when we are adding HCl to NaCl, okay, NaCl, HCl is passed to a saturated solution of NaCl. So, what is happening to the solubility of NaCl? It will decrease. So, option number B is the answer. Okay. Aqueous solution of acetic acid contains. So, what does the aqueous solution of acetic acid contains? What does the aqueous solution of acetic acid contains? What does the aqueous solution of acetic acid contains? So options are given. Yes. So we have already discussed in the synopsis. Acetic acid is a weak acid. So what does a weak acid consist of? It will consist of what? Okay, suppose I have acetic acid. Okay, and add in water. Okay, I will add in water. So it will get dissociated. So how it will get dissociated? It will get dissociated into acetate ions plus hydronium ion. Right. So it will get dissociated into acetate ions, hydronium ions. Okay. And the acetic acid. So option number B. Option number B. Okay, option number B is the answer. So acetate ions, hydronium, and acetic acid. Okay. Next. So this we have seen. Okay. H2S gas, when passed through a solution of cations containing HCl, HCl precipitates the cations of second group of qualitative analysis, but not those belonging to fourth group. It is because of A, presence of HCl decreases the sulfide ion concentration. B, solubility product of group 2 sulfides is more than that of 4 sulfides. Presence of HCl increases the sulfide ion concentration. D, sulfides of group 4 cations are unstable in HCl. Yes. HCl gas. Okay, this is we observe this at when we do qualitative analysis. Okay, at a higher level. So when we are doing qualitative analysis, okay, when we are finding out the cations and anion in their practicals, right? We are passing H2S. First test is salt plus dilute HCl. Second test is salt plus dilute HCl plus H2S, right? So that time, what was happening? They're saying that cations containing HCl's precipitate the cations of group 2. Okay, sometimes it will give you PPT, but not those belonging to fourth group. Why? What is the reason? Fourth group. Okay, so for fourth group, what will happen? The higher sulfide ions are required. Okay, so when you add HCl, okay, in the presence of HCl, what will happen? The dissociation of H2S decreases. Okay, so what will happen? The amount of sulfide ion produced will be less. Why? Due to common ion effect. So HCl decreases and the solubility of H2S, what will happen? It will be sufficient. Okay, so that it will get precipitated in the second. So what is the answer? A. Presence of HCl, what will happen? It will decrease the sulfide ion concentration. Okay. So this we see in the, yes, very good. Okay, Hema has answered. Very good. Okay, so this we have, this we experience when we do the qualitative analysis, when we find the cation and anion, right? So that time. Okay. Okay, about buffer solution, which is incorrect. It contains a weak acid and its conjugated base. It contains a weak base and its conjugated acid. It shows change in pH on adding small amount of acid or base, all of the above. Yes, what is the answer? What is the answer? We have discussed this theory part. Yes, about the buffer solution. What do we have discussed what is buffer solution? Yes, buffer solution, two types of buffer, weak acid, acidic buffer and basic buffer. Okay, so acidic buffer is formed with what? Weak acid plus its conjugated base. Okay, when you have a weak acid and conjugated base, it is a acidic buffer. It is a acidic buffer. Then when you have a weak base, plus its conjugate acid, it will give you a basic buffer. Okay, it will give you what? Basic buffer. Okay, and what is a buffer solution? What it does, it resists the change in the pH. Okay, by adding one drop or the base, right? So what is it contains weak acid and conjugate base. So this is, it contains weak base and its conjugate acid. It shows change in pH on adding small amount of acid or base. Okay, so all the above are correct. Okay, all the above are correct. Right, so it contains, no, they have asked about the buffer. Okay, only of buffer. So option number C is correct. This is for acidic buffer, this is for basic buffer. So they have asked only with respect to buffer. So option number C is correct, not a D. Okay, C is correct. Understood? So this is with respect to acidic buffer. They have not asked about acidic buffer, or they have not asked about basic buffer. They have asked about what? They have asked about buffer. Okay. So what it does, it resists the change in pH on adding small amount of acid or base. So option number C is the answer. Okay. The compound whose aqueous solution has the highest pH is. So the compound whose aqueous solution has highest pH is how much? The compound whose aqueous solution has the highest pH is NaCl, NaHCO3, Na2CO3, and NH4Cl. So when we see NaCl, okay, when we see NaCl, NaCl is a what? It is a salt, okay, obtained from strong acid, right? Strong acid. So when HCl and your NaOH combines, okay, what you are going to get? NaCl. So with strong acid and strong base, when strong acid and strong base is dissolved, okay, in the what will happen to the this your neutral solution, okay, your solution will turn neutral. Okay, so the pH will be what? pH will be 7. So NaCl is what? It is a salt which is obtained when strong acid and strong base is okay, it is mixed, right? So and what will happen to the aqueous solution? It will be neutral, that is pH will be 7. Then NaHCO3, sodium hydrogen carbonate. So what is that? This is a acidic salt. This is a acidic salt. Why? Because pH is less than 7. Okay, its pH is less than 7. Then Na2CO3. Na2CO3, this is a salt of weak acid. Okay, this is a salt of weak acid and strong base. So when you have a strong base and a weak acid, this salt is obtained. Okay, and its pH is what? It is greater than 7. It is greater than 7. Then NH4Cl. NH4Cl. How NH4Cl is obtained? It is a salt of weak base, okay, and strong acid. Okay, and this is completely acidic. So pH is less than 7. Okay, so answer is what? They have asked who has the highest pH. So highest pH is of your option number C, that is NaHCO3. Okay, NaHCO3. Na2CO3. Okay, Na2CO3, that is sodium carbonate. Okay, sodium carbonate. Point 0.1 molar solution of which of these substances will be basic? A. Sodium borate, B. Ammonium chloride, C. Calcium nitride, and D. Sodium sulfate. 0.1 solution of which of the following will be basic? Yes. So it is sodium borate. Why? It is a salt of NaCl, NaOH, okay, and boric acid. Okay, boric acid. When they react, they give you sodium borate. Okay, you get what? Sodium borate. So Na. Okay, so it will be sodium borate. So 0.1 solution of which of this substances will be basic? So it is obtained when NaOH, which is a strong base, okay, it gets combined with a weak acid. Okay, and what will be the aqueous solution? It will be a base. Okay, so the aqueous solution will be basic in nature. Sodium borate is basic in nature. So option number A is the answer. Option number A is the answer. Okay. The pH value of blood does not appreciably change by a small addition of an acid or a base because the blood is a body fluid, can be easily coagulated. C contains iron as a part of molecule. D contains serum protein which acts as buffer. So what happens to the pH value of blood does not, why it does not change by small addition of an acid or a base? What happens to the pH? The pH value of the blood, it does not appreciably change. Okay, even after you add any acid or base. What? Because why? So the in your blood, okay, H2CO3 plus NaHCO3, okay, hydrogen carbonate and your sodium hydrogen carbonate is present. Okay, so buffer solution, what we know that it will resist the change in pH. Okay, so therefore what will happen? The pH value of blood does not change. Okay, even after addition of blood or your acid or base. So it is option number D. So why? Because the blood contains what? It contains the serum protein which acts as a buffer. Okay, so serum serum. Okay, what does that serum consist of? Your H2CO3. Okay, hydrogen carbonate plus sodium hydrogen carbonate. So because of that, what is happening? Even after you add the buffer, it is not changing its pH. So option number D is the answer. Okay. What is the H plus concentration of a solution prepared by dissolving 4 grams of NaOH? Atomic weight of sodium is 23 in 1000 ml. So how do you calculate number of moles? First, you have to calculate the number of moles. Okay, number of moles is what? Given weight upon the molecular weight. Given weight upon molecular weight. What is the given weight? 4 grams. Molecular weight is of NaOH. Sodium is 23, oxygen is 16, hydrogen is 140. Okay, it is 40. It is 40. Okay, so 10, it is 0.1. Okay, it is 0.1. So number of moles of OH minus is 0.1. So concentration of OH minus is what? Number of moles of solute upon volume of solution, that is 0.1 by 1000. That is how much? 0.1 mole per liter. Okay, so what is the concentration of your H plus? So it will be H plus and that is your ionic product. Okay, that is H plus and OH minus is equals to 10 raised to minus 14. So H plus is equals to what? What is OH minus is 0.1. Okay, so H plus will be 10 raised to minus 13 because your OH is how much? It will be 10 raised to minus 1. So it is how much? It is minus 30. So it is option number D, 10 raised to minus 13 molar. Got it? Is it clear up to here? Fine. Let us go for the next one. Okay. So this is the question based on solubility. Solubility of a M2S salt is 3.5 into 10 raised to minus 6. Then its solubility product will be. So M2S, okay, M2S. So if it splits, it will split into 2M plus and X minus, right? So this will be 2 into some X and this is X. So solubility product, how it is given? Solubility product. So solubility product is equals to product of 2x square into x is equals to 4x cube. Okay, is equals to 4x cube. So that is 4 into x is how much? X is the solubility of M2S salt is 3.5 into 10 raised to minus 6 into 3. So how much it is coming after solving? Just see. Yes. So after solving, I am getting 1.7 into 10 raised to minus 16. Option number A. Option number A. Are you getting the same? So solubility product. Solubility product is what? Concentration of the products, right? Concentration of your 2m plus x minus. That is, if I consider this as 2x, so 2x square into x, that is 2 square is 4. And x square is x square into x is 3. So x cube, right? So put the values of x, we have the solubility. So it is 3.5, right? So we are going to get 1.7 into 10 raised to minus 16. So very important, okay? Remember the formulas. Calculate the pOH of a solution at 25 degrees Celsius that contains 1 into 10 raised to minus 10 molar of hydronium ions, that is H3O plus. How you are calculating this? Hydronium ions. Concentration is how much? 1 into 10 raised to minus 10 molar. Okay, at 25 degree. So hydronium into OH minus is equals to 10 raised to minus 14. Okay, so what we have to find? We have to calculate the OH. So OH is equals to 10 raised to minus 14 divided by 10 raised to minus 10, that is 10 raised to minus 4. Now we know that OH minus is equals to 10 raised to minus P of OH, that is 10 raised to minus 4 that is 10 raised to P of OH, that is POH is equals to 4. So option number A. So ionic product, okay, that is hydronium ion into OH minus, that is the sum will be equal to 10 raised to minus 14. So after just substituting, okay, we are going to get this final answer. Option number A. Okay. The ionization constant of ammonium hydroxide is 1.77 into 10 raised to 5 at 298 Kelvin. Hydrolysis constant of ammonium chloride is. So the ionization constant, okay, is equals to constant of W upon B. So what is the concentration of your water? The ionization constant of hydronium hydroxide, okay, ammonium hydroxide of your base is how much? 1.77 into 10 raised to minus 5. And of your water is 1 into 10 raised to minus 14. So after solving this, ammonium chloride, okay, how you obtain this ammonium chloride? Ammonium chloride, it is obtained how? With the salt of weak base and strong acid. After solving this, I have got 5.65 into 10 raised to 10. Option number D. Option number D. Are you getting the same? Okay. So in a buffer solution containing equal concentration of B minus and HB, the HKB for B minus is 10 raised to minus 10. The pH of buffer solution is. So what all is given, let us write Kp is equals to 10 raised to minus 10. Then K is equals to 10 raised to minus 4. Why? Because the concentration of the your acid plus base, okay, equilibrium constant of acid plus base is equals to 10 raised to minus 40. So if you take that 10 raised to minus 4, okay, or the pKa, it will be 4. pKa will be 4. So if your buffer solution is containing equal concentration of B minus and HB, okay, so pH will be equal to pKa plus log of 1 plus log of 1. So pH will be equals to pKa is equals to pK is 4. So if you have a so 4. So if a buffer solution containing equal concentration of B minus and HB, so in a buffer solution containing equal concentration of B minus and HB, the Kb for B minus is 10 raised to minus 10. The pH of buffer solution is. So it is 4. Okay, after solving this. I hope you have got it. Fine? Okay. Solubility we have done. This is the question. When a buffer solution, sodium acetate and acetic acid is diluted with water, what will happen? What will happen? The H plus ion concentration, what will happen to the H plus ion concentration? It will remain unaltered. Okay, whenever you are adding any buffer solution, small amount of acid or base, it will not alter anything. Okay, so it is option number D. So H plus ion concentration will remain unaltered. Okay, there won't be any change in pH. So it is option number D. Based on theoretical, okay. The product of ionic concentration in a saturated solution of an electrolyte at a given electrolyte at a given temperature is constant and is known as. The product of ionic concentration in a saturated solution of an electrolyte at a given temperature is constant and is known as A. Ionic product of the electrolyte. B. solubility product. C, ionization constant. D, dissociation constant. Yes, what is it? It is solubility product, right? It is the solubility product. So the definition is of solubility product. So solubility product is what? It is ionic concentration in a saturated solution of electrolyte at a given temperature, which is constant. Okay. So it is the solubility product. So by this, we have completed the questions on equilibrium. Okay. So this completes your PU1 syllabus. Okay. So I have, so your PU1 syllabus completely we have finished for your CET exams. Okay. So completely the CET portion has been completed. So this was the last chapter which I had to discuss. So yes, any doubts in today's session? Any doubts in today's session? So most of the questions, okay, from this chapter we have covered. So I have taken the which are things are asked, okay, basically which concepts are more important. So from that concepts we have taken, we have solved questions, okay. So again, so you can also if you have any book or you can solve some previous year questions, okay, and you can solve some good number of questions so that it will help you. So whatever things we have discussed here, okay, you can same apply there, and you can see how much you have understood. Okay, so whatever the synopsis, okay, are sent to you, so please go through them. Okay, so you can also go through our ACE classes. Okay, no, so you can go to the synopsis which are sent to you. Okay, so there we have already discussed. Okay, so in depth, so whatever the from CET point of view, whatever it is important, so on that we have concentrated and we have solved the questions. Okay, so yes, any doubts? Okay, so thank you, dear students. So I hope you do well, okay, in your board exams and in your further competitive exams. Okay, so we will see you soon in the uh, with some, okay, so in some good time we will see you back. Okay, yes. Okay, so I'll end the session here. Okay, thank you.